Welcome to the deep dive. Today we're tackling something pretty crucial for anyone aiming for those senior software engineer roles in Java.
Oh, yeah. What's on the docket?
Object comparison and sorting. You know, the stuff that always seems to pop up in technical interviews.
Ah, yes. Comparable and Comparator, definitely core Java knowledge.
Exactly. And it's not just about, like, knowing collections.sort exists, right? It's about really getting what's happening underneath. That seems to be what interviewers are looking for.
Totally. It shows a deeper grasp. It's demonstrating you understand how Java lets you define order, which is, well, fundamental for so many algorithms and data structures.
Okay, so our mission today then is to really nail down comparable and comparator. When to use which, how they work, maybe some common traps.
Sounds like a plan.
Yeah.
It'll definitely help folks feel more confident going into those interviews.
All right, let's start right at the beginning. Why do we even need to compare objects in the first place? Seems basic, but maybe it's not.
Well, think about sorting.
Yeah.
It's everywhere, right? You have a list of users, products, transactions, whatever. You often need them in a specific order.
Like sorting users by sign-up date or products by price.
Exactly. And the sorting algorithm itself, whether it's merge sort, quick sort, whatever Java's using under the hood, it needs a consistent way to answer a simple question. Given these two objects, which one comes first?
Ah, okay. Without that rule, the sorting algorithm just can't function.
Pretty much. It's lost.
Yeah.
And the rules can be totally different depending on what you're comparing. Comparing strings alphabetically is, different from comparing numbers numerically, or maybe comparing employee objects by their employee ID, or perhaps by salary.
Right. So Java needs mechanisms to let us define those specific roles.
Precisely. And that brings us to the first mechanism.
Which is comparable, I'm guessing?
You got it. The
Yeah.
comparable interface. It's Java's way for a class to basically say, hey, I know how to put myself in order relative to others of my kind. It defines the class's natural ordering.
Natural ordering, like alphabetical for strings or numerical for integers.
Exactly. Those are perfect examples. For many standard Java classes, the natural order is pretty intuitive. String, date, numeric wrappers, they all implement comparable.
So when you implement comparable, you're kind of deciding on the main default way objects of that class should be sorted.
That's the core idea.
Yeah.
And you usually see it with what's called a type parameter, like comparable T. That T is just a placeholder for the type you're comparing against.
So for an employee class, it'd be comparable employee.
Correct. It means this employee object knows how to compare itself to another employee object. It makes the whole thing type safe.
And the actual comparison logic is in one specific method.
Yep, just one method you need to implement. Compare T other. Takes one argument, the other object you're comparing against.
And it returns an integer, right? What do the different values mean?
Right, an integer. And it's the sign of the integer that matters.
Right.
If A dot compared to B returns a positive number, it means A comes after B.
Okay.
If it returns a negative number, A comes before B.
And 0.
0 means they're considered equal, at least for sorting purposes. They might not be identical objects, but in terms of order, they're at the same level.
Ah, okay. So it doesn't have to be exactly 1 or -1, just positive and negative. I think I might have thought it had to be specific values.
That's a really common misconception and definitely something to be clear on for interviews. The spec only cares about the sign. This gives you some flexibility, like if you're comparing employee objects based on an integer ID.
You could just subtract the IDs?
Often, yeah. A simple implementation might be return this .id other .id. If this .id is bigger, you get a positive result. If it's smaller, negative. If they're equal, 0.
Simple. But I feel like there was a catch. Something about potential problems with just subtracting.
Ah, good point. Yes, you have to be a bit careful. Integer overflow.
Right.
If the IDs can be very large, or especially if one is large positive and the other is large negative, the subtraction itself could wrap around, giving you the wrong sign.
So what's the safer way then?
The recommended approach in those cases is to use the static helper method. Integer.compare, this .id, other .id. It handles all the edge cases correctly. No overflow risk.
Okay, good to know. Use Integer.compare to be safe.
It's definitely safer. Though if you know your IDs are, say, always non-negative and the difference won't exceed integer limits, direct subtraction is sometimes seen. But Integer.compare is generally better practice.
What about non-integer fields, like comparing based on salary, which is probably a double? Can we just subtract doubles?
Oh, definitely not. That's even trickier. Floating point arithmetic has precision issues. Subtracting them directly can give you tiny errors that mess up the comparison.
Okay, so no subtraction for doubles. What then?
A similar solution.
Okay.
Use the static helper method double.com compare this.salary, other.salary, or float.compare if you're using floats. These methods handle the nuances of floating point comparison correctly, including weird stuff like nan and infinity.
Makes sense. Use the built-in compare methods for primitives, basically.
It's a robust way. And another interesting point that sometimes surprises people, inside that compareTo method, you can access private fields of the other object.
Oh, yeah. Like other.salary, even if salary is private.
Exactly. Because the method belongs to the employee class, it has access privileges to any employee object's members, even private ones. That's just how Java's access control works within a class.
Huh. Okay, good detail. So we've got our employee class. It implements comparable employee. We've written the safe compareTo. How do we actually sort an array of these employees?
Easy peasy. The java.util.arrays class has a static sort method. If your employee objects are in an array, say employee array, you just call Arrays.sort employee array.
And it automatically uses the compareTo method we wrote.
Yep. It assumes the objects in the array are comparable and uses their compareTo method to figure out the order. Works for collections.sort too, if you're using lists.
Nice. But didn't the source material mention a potential runtime issue here? Something about compile time.
Ah, yes. Another key interview point. The compiler doesn't check if the objects in the array actually implement comparable.
Uh-oh. So what happens if they don't?
You get a runtime surprise, a class cast exception. The sort method tries to cast the object to comparable to call compareTo, and if it can't, boom.
Ouch. So you need to be sure your objects are comparable before you call the basic arrays.sort.
Exactly. It's a runtime contract, not a compile time guarantee.
Okay, so comparable handles the natural order baked into the class. But what if that's not the order we need right now? Like, strings sort alphabetically naturally, but what if I need them sorted by length?
Perfect segue. That's precisely where the other interface comes in, comparator.
Right, the alternative ordering strategy.
Exactly. Comparator lets you define comparison logic outside of the class being compared.
Yeah.
You can create separate classes, each implementing a different way to compare the same type of object.
So for strings, I could have one comparator for length, maybe another for reverse alphabetical order, another for, I don't know, number of vowels.
You absolutely could. Each comparison logic gets encapsulated in its own comparator object.
And how does comparator work? Does it also have a compare method?
It does. It's slightly different, though. The interface is comparator T, and the method signature is compare. T first, T second. Notice it takes two objects to compare.
Ah, unlike compareTo, which is called on one object and takes the other as an argument.
Precisely. The comparator's compare method looks at both objects from the outside, so to speak. The return value convention is exactly the same, though. Positive if first comes after second, negative if before, 0 if equal, according to the specific comparator's logic.
Okay, let's take that string length example. How would we write a comparator for that?
You'd create a new class, maybe call it length comparator, that implements comparator string.
Okay.
Inside that class, you implement the compare method. It would look something like public int compare string first, string second, return first dot length, second dot length.
Ah, using subtraction again. Is that safe here? Lengths or ints?
Good question. String lengths are non-negative integers. The difference between two lengths is highly unlikely to overflow a standard int. So in this specific case, direct subtraction is generally considered okay and is quite common. Using Integer.compare first.length is also perfectly fine, just a bit more verbose. Got it. So this length comparator, when used, will put shorter strings before longer strings. Correct. Now, there was a point about needing an instance of the comparator even if it doesn't have any state, like our length comparator. Why can't compare just be static sometimes? It comes down to the interface definition. Comparator defines compare as an instance method. So to call it, you need an object, an instance of your length comparator class. Even if that instance doesn't hold any data itself, the Java language requires an object to invoke an instance method. It's just how interfaces and polymorphism work here.
Okay, fair enough. Instance method needs an instance. So how do we use this length comparator instance with Arrays.sort? Is there a different version?
Yep, there's an overloaded version of Arrays.sort. It takes two arguments, the array you want to sort and an instance of the comparator to use for the comparison.
So if I have my string names, I'd call.
You'd call Arrays.sort names, new length comparator. You pass in the array and a new instance of your custom comparator.
And Arrays.sort will then use the compare method from that length comparator object instead of looking for a compareTo method on the strings themselves.
Exactly. It completely overrides the natural ordering for that specific sort operation.
What happens if strings have the same length? Using that length comparator, their compare result is 0. Does Arrays.sort keep them in their original relative order?
Not necessarily. The documentation for the basic Arrays.sort using a comparator doesn't guarantee stability,
Stability, meaning.
meaning it doesn't guarantee that elements that compare as equal will retain their original relative order after sorting. So if you have Paul and Mary, both length 4, after sorting by length, they might end up as Paul, Mary, or Mary, Paul. All the sort guarantees is that they'll be grouped together relative to shorter or longer strings.
Ah, okay. So if the original relative order of equal elements matters, you might need to look into stable sorting algorithms or maybe more complex comparator.
Right. Or sometimes the specific sort implementation used by Arrays.sort might be stable,
Mhm.
but you shouldn't rely on it unless the documentation explicitly says so for that version or context.
This makes things much clearer. So wrapping this part up, how do we choose? One comparable, one comparator.
Okay, the key distinction. Comparable is for defining the one primary natural ordering within the class itself. Think of it as intrinsic to the object's definition.
Like the default sort order.
Exactly. You use comparator when you need alternative sorting strategies, maybe multiple different ways to sort the same objects depending on the context.
Or when you can't modify the class you want to sort right, like standard Java classes or third-party library classes.
Precisely. If the class doesn't implement comparable, or if it does but its natural order isn't what you need right now, comparator is your tool. You create an external definition of how to compare those objects.
So for my employee example, ID is probably the natural order, so implement comparable in employee using ID. But if I sometimes need to sort by salary or hire date or last name,
You'd write separate comparator employee classes, a salary comparator, a hire date comparator, a last name comparator, and so on. You pass the appropriate comparator to Arrays.sort when you need that specific order.
got it. Comparable for the built-in default, comparator for everything else.
That's a great summary. It gives you both a standard way and the flexibility for custom needs. Understanding both and when to apply each is really powerful.
Yeah, this deep dive definitely cleared things up. It's way more than just calling sort. Knowing the difference, the implementation details like using Integer.compare or double.compare, the runtime exceptions, that feels like senior level understanding.
It absolutely is. Being able to articulate why you'd choose one over the other or how you'd implement compareTo safely, that's what interviewers are listening for. It shows you understand core Java design principles.
Okay, so key takeaways. Comparable defines natural order via compareTo inside the class. Comparator defines custom external order via compare in a separate class. Use comparable for the default, comparator for alternatives, or when you can't change the original class.
Nailed it. And don't forget the practical bits, like using helper methods for comparisons to avoid overflow or floating point issues, and being aware that the basic sort relies on a runtime check for comparable.
Fantastic. This has been incredibly helpful. For everyone listening, especially if you're prepping for interviews, really think through some scenarios. When would you reach for comparable versus comparator in code you've written or might write?
Yeah, and maybe a final thought to chew on. Imagine you have a really complex object, lots of fields, user profiles, configuration settings, whatever. How would you decide on its natural order for comparable? What factors make an order feel natural? And then think about all the different ways you might need to sort those objects later. What comparator implementations would you need to create to handle those diverse use cases? Musing on that could really solidify these concepts.